We're going to be looking at example 6 in your section 3.3 notes. So in this example, we're given that the sine of alpha is negative 7 over 25, and we know that alpha ends up being in quadrant 3 because of the range that we're given. So we're going to go ahead and draw the picture for that. Okay, so alpha comes all the way over to quadrant 3. Okay, our reference triangle will be here. Since we're dealing with the sine, the opposite side will be negative 7. The hypotenuse will be 25, and we have to find that x value. Okay, so Pythagorean theorem gives us x squared plus negative 7 squared, or 49, is equal to 625 when we square the 25. We're going to get x squared is equal to 576, and when we take the square root of that, we'll get 24, but we want to make sure that we keep a negative because we are on the negative side of the x-axis. So this will be negative 24 there, okay? All right, so I've written down the half angle identities for both the cosine and the tangent. When we do the cosine, we have a plus or a minus we need to pick out, and that relies on alpha over 2, the angle. So we're not going to be able to actually find alpha over 2, but we can find a range for it. So if we divide the original by 2, we're going to get 90 degrees, okay, less than alpha over 2, and then that's less than 135 degrees. So we're going to be able to see that alpha over 2 ends up being in quadrant 2. Okay, now since alpha over 2 is in quadrant 2, when we're dealing with cosine, we're going to have a negative answer because cosine is negative in quadrant 2. Okay, all right, next thing I want to do is use my picture to figure out what the cosine of alpha is. So this is where my x value I found is going to come into play. So adjacent over hypotenuse, I'm going to get 1 plus negative 24 over 25. Okay, and that's all over 2. Okay, so next thing I would do is I would get rid of this fraction here by multiplying both the top and bottom by 25. Okay, so multiplying through the top, I'm going to get 25. Okay, and then plus minus, go ahead and just put that minus sign down. So it'll be minus 24 all over 50 down there, so looking a little bit better. Okay. So I'm going to get negative square root. I'm going to get 1 over 50, okay? So we can definitely rationalize this a little bit if you want. If you left it as 1 over root 50, I'd be fine with that when you're in the classroom. I'm going to go ahead and rationalize, though. So 50 has a 25 times 2, so I can rewrite that as 5 root 2. Then I'm going to multiply the top and the bottom by the square root of 2. So I can get negative root 2, and then that's going to be 5 times 2. So we'll get all over 10 there, okay? All right, so for part B, there are different versions for the tangent of alpha over 2, and I picked this one. I typically try to stay away from the square root version if I can. So I'm ready to go ahead and plug in the values according to my picture. So the cosine of alpha, we already know, is going to be the negative 24 over 25. Okay, the sine of alpha, we know, is negative 7 over 25. Okay, so we're going to do the same thing again. We're going to multiply by 25 to clear out those extra fractions that we just put in there. Okay, so 1 times 25, we'll have 25. We'll have a plus sign, okay, and we'll end up with a 24. Okay, here the 25s will cancel, so I'm just going to be left with the negative 7, so already looking a lot better. Okay, adding the numerator, we'll get 49 divided by negative 7, and we get a really nice answer of negative 7 for part B. That does it for example 6.